So this is the fifth and final video of my current series detailing how to perform ChIP-seq analysis on Galaxy. So what I'm going to talk about is how we can take our workflow that we've generated over the last few videos and create a reusable Galaxy workflow. And what this means is that we can more or less save the flow of data for all these different jobs and create this workflow where we only need to enter a minimum amount of information to make it easier to run again and again. So a workflow saves you time, but it is also something that you can share with other people, which means that they can use your method exactly the same way you did it. So some of these tools like Max had lots and lots of different parameters we had to set, but using the workflow this means the next time you run it they'll be set just the way you want. So to create a workflow we click on the cog icon at the top right hand side of the screen, and there we find an option called Extract Workflow. So if we click on that, this shows all the components of the workflow that are taken directly from our history. Now we don't need the first two boxes ticked because that was imported data, and Max itself will call for that data and it'll make a lot more sense where that data is coming from, but I'll show you that later. So everything else that's been extracted from our history is good to go for our new workflow. We need to give it some sort of meaningful name as well, so we can call that ChIP-seq for MM9. Now our new workflow will be able to use any chip and input file that we provide. So we use just chromosome 1 in our example, but in a real analysis you would want to give it the reads for the whole genome. Okay, so that's fine, so we can now create our workflow. And we can find our workflow under the Workflow tab at the top of the screen. Okay, so here's our workflow. The ones underneath are ones I used in preparing this tutorial, amongst other things. So you can click on that with the left button, and the first thing we want to do is edit. So the edit screen shows us all the components of our workflow. Each of these boxes is one of the elements of the workflow, and you can left click and hold and you can move those about. Now how you position them doesn't really affect things, apart from if you have different input files for the workflow, their proximity to the top left hand side of the screen does give them order of precedence. However, in this case it doesn't really matter how we set things up, so I'm just going to reorganize these to make it a bit easier to see what's going on. So we've got Max, and we can see that the some of the output is linked to CEAS, so the outputs, the output summit file and the treatment wig file, that goes into Max, and that's a kind of standalone a standalone task. We don't use the output for any of the downstream analysis. Now then what we did is we used the compute function to get the coordinates 100 bases up and downstream of the summit. So here we have, this is the summits file, and that goes through to compute, that's minus 100, compute based on this plus 100, and then we cut out the columns that we wanted. Also we had this filter for the main output file where we filtered by false discovery rate and fold enrichment. We were then able to determine which of the summit regions overlapped with our filtered high quality binding regions. All of that went into the we used it to extract sequences that belonged to these summit regions, and then that was fed into Weeder. So that's our pipeline. Now when you left click once on these boxes, it brings up detailed information about that task on the right hand side. Again, you can use this slider to make things wider and clearer to read. So these, all the options that are in Max are exactly the same as when we ran it in our previous history. Now these items will be kind of set in stone in our workflow. So we won't be able to change this, won't be able to change this, won't be able to change this, because that's how we've set the workflow up. If you think you want to so I've just done something odd with my screen there. That's better, sorry. If you want to say right, I might want to use a different bandwidth in other experiments, then you could click on set at runtime. So I was just left clicking on that arrow there, and that means that when every time you run the workflow, you will have to manually edit the bandwidth option. So I've called my workflow ChIP-seq for MM9, so I don't want to have to change this every time. It will be set for the mouse genome. However, if you wanted to make a more widely applicable workflow that could work for different genomes, you would also set that to set at runtime. However, I'm just going to leave this as we performed it in our history. This goes for all the other items of our workflow, CAS. Now interestingly, this has gone back to its normal default, so it is worth clicking through each item just to make sure. So we need to select that as mouse MM9. And yeah, lower 500, middle 1000, upper region 10,000, so everything else is the same. So that's okay. Here we have our first compute expression, C3 minus 100. Remember we rounded there. We then took that result and we added 100 to C3 and rounded. And then we cut out columns 1, 6 and 7 to be used in the downstream analysis. Now one important thing here, if you remember, we had to change the file type of the result of cut. So what we can do is change the data type for the output of cut. So this is under Edit Step Actions, change data type, create, and it is a interval file, so I'm just going to type int, and that brings us to interval. Left click on that, and then that's set fine. What else we got? So then we had our filter, so that was C9, so filter out all regions where C9, which is the fault discovery rate, was less than 10. So then from that, a result of that filter, we took the regions that were obviously already FDR less than 10, but then also filtered by column 8, where fold enrichment was greater than or equal to 10. The output of that was already an interval, so we don't have to do anything else there. Then we have our intersect, so overlapping intervals, so that's fine. So of input 1, which is this one, the summit regions, 200 base pair summit regions, that intersect with our filtered binding regions. The output will be an interval, so that's fine. We are extracting sequence based on the coordinates of those filtered summit regions, based on the default genome, which was mouse MM9, and then that finally feeds through to Weeder, where we run a with a mouse specific background, motifs 6 and 8, both strands of the genome, allowing for multiple occurrences of each motif, and up to 10 discovered motifs in our report, and that's it. So that's fine. So we've gone through in detail and checked that everything is okay. You then have to save, and that is our workflow ready to use. Okay, so to run our workflow, we can go to the cog icon and select run. So that brings us back to our analyze data area and shows us all the steps of the workflow with customizable options. So remember, effective genome size, we can't change that because we didn't set the set at runtime option. So the only thing we can actually set is our chip input file and our ChIP-seq control file, which is the input. So that's we don't want to run it in this history, because otherwise you'll get all the results of the workflow in this history. The best thing is to start a completely new history. So we can see that basically the only things you can change for this history are the like I said, the input the tags for the IP and the tags for the input reads. Again, if you go down, the only other thing that is available to change is the user specified bed file. Everything else we set in our workflow. So hopefully you can see that by running this, by creating this workflow, everything is set, and all we need to do is change these two input files. So this just makes everything very reproducible for other people and even ourselves. One thing I forgot to mention is that we really want some accompanying notes with all this. So if we go back to workflow and edit, when you click on each of the boxes in the workflow, at the bottom of each one there is a Annotation Notes section. There'll be some information that's already provided by Galaxy itself, but it's also good for yourself and other people if you put a description of what the particular step is doing. For example, that you've set it to be useful for mouse only, and for example in the cut function, the fact that you've changed the file output to an interval. I've actually provided a example of a workflow in my Galaxy page. It seems like a good point to remind us where that is. So under shared data, published pages, and then we click on basic ChIP-seq workflow. I've written a more detailed description of all the steps in the ChIP-seq workflow. So we have the peak calling step, there's a website for the Max software, the accompanying publications and a little description, and I've done this for Max, for CEAS, for Weeder, and at the bottom I've included a workflow that I made to accompany this tutorial. So this plus button allows you to see this workflow. So you can see here that I've annotated the Max step here. This is the annotation that I added to explain this step, and you can see that I've done this for each section. So there's a bit for CEAS, I've explained the compute steps, etc. Also I'm able to embed the history that I created. So like the history we created in this tutorial, this is the history that I originally produced and then used to create the workflow. So this looks just like we've produced in this series of videos. In the Galaxy page, where there are the example workflow and history, you can import them into your own sessions by clicking on this plus button. So in this case this will import the workflow into your account, and this will import the history into your account. So once you've created a workflow, you may want to share it with other people in your group, or the other option is to share it with everybody else who has access to this instance of Galaxy. In order to do this, you would go to the workflow tab at the top of the screen and select share or publish from your workflow link. Now there's several options available. You could just share your workflow with a particular user. You could create a link that you could send to people and they could import your workflow into their own account. The alternative is to make the workflow publicly accessible. by doing this, it also allows people to import using this link, but it also makes it accessible via the shared data tab. So if we now look under published workflows, we can see it has appeared here. So last date updated less than a minute ago. Okay, so I'm just going to go back to the workflow screen, and I'm just going to turn that off. So share and publish. Again, this is an example of if you change your mind, you can then unpublish the workflow and disable that link. And that's how you share your workflow.
So I'm going to draw this series of videos to a close now. I hope it's given you some insight in how to perform ChIP-seq analysis using Galaxy, and some other things to think about when performing this type of analysis. Thanks very much. Bye.